Okay, thank you, everybody. Yes, so 400 gig, easiest way to go faster is to go faster. My name is Sean Flack, one of the systems engineers at Arista. So Ethernet speed transitions have been the primary driving force really to improve the throughput and cost performance of any network. So to go, to add more speed to your network, use a higher speed link, as it were. And this has really been driven by, and we've kind of seen this in the semiconductor world with Moore's law. So Gordon Moore, 1964-5, predicted that every 2 years, the number of transistors per component would double. And this has proven itself for the past 50 years or so. So in 40 years up to 2011-ish, we saw a 1 million times increase in the number of transistors per component. To put this into a bit more perspective, in the last 12 years, we've seen a 100-fold increase in the number of transistors per whether that be a processor or memory. And this has also kind of lent itself over to network devices as well. And we've seen from about 2008, really, whereby the first kind of merchant silicon type devices out in the market from Intel, which is Intel now, was kind of the Barley chipset with about 24 ports of 10 gig. And we've seen consistently over the last 10 years or so that every year, the number of ports, or I should say the throughput per chip, has doubled every 2 years. And this kind of line here, and you might recognize some of the products on here, the Broadcom Trident chipset, Tomahawk, Tomahawk 2, and Tomahawk 3, which we're up to about nowadays. Kind of matches that line. Every 2 years it goes up by 2, or kind of doubles every 2 years. But you'll actually notice that the other kind of product set, which is kind of the more feature-rich product set from the likes of Broadcom, and also there's a few other vendors out there like Barefoot Networks, whereby they're actually increasing the throughput by more than 2 times per year. And this is really because switching chips are actually lagging behind CPU chips. So only about 10 years ago, switch chips were using a process, a 65 nanometer process, which is already about 4 to 6 years old at the time. So switch chips are still kind of catching up with CPUs, which means that Moore's law is very much alive and well in the networking space. And you're going to start to see faster and faster switches or routing chips out there. But every time we kind of increase the speed, the price doesn't go up, the price doesn't change. So if you're looking at a 64 port, 100 gig device today, in 2 years time, that will become a 64 port, or a 128 port, 100 gig switch. And the price just won't increase because the likes of Broadcom, Barefoot, Intel, and these merchant silicon manufacturers aren't increasing as the speed goes up. So this kind of the gap is kind of closing and is very much alive in the switching space. And what does this look like from the actual speed or throughput that you get per switch or per router? Only I say 10 years ago, up till today, we're seeing this doubling in speed and number of ports per switch. So around about 2017, we're seeing about 64 ports of 100 gig using the Tomahawk 2 chipset. The Tomahawk 3 came just 2 years later, and we saw this increase from 64 ports of 100 gig up to 128 ports of 100 gig in a single chip. And then next year, we should expect there to be a Tomahawk 4, which will then increase this to 256 ports of 100 gig in the same size chip, using the same amount of power or using less power. But on top of this, you're also getting more features, bigger table sizes, and that's why it's kind of it's been seen as important to keep up with the latest chips, to make sure that you're taking advantage of the latest features, table sizes, and interface speeds out there as well. So why do we 2020, 2021, 400 gig sounds like a very, very high speed link? Why do we really care about this today? And this is really to do with matching internet or interface speeds to the switch silicon speeds. So you might have, I'm sure many of you are using 100 gig today. And this is actually from the electrical side of things. This is using 4 lanes of 25 gig to place a 100 gig link onto the fiber, as it were. And the natural match to this would be the Tomahawk 2, which uses 25 gig SerDes or 25 gig electrical lanes on the switch side. Now the problem is, if you want to use a newer switch or a newer router with more features and more or bigger table sizes, in order to match the 100 gig optics to that particular switch, you require an extra component in the switch itself called a gearbox, which basically adds more power, makes the box much more expensive, and ultimately is more expensive, more cooling, more power is required, and also reduces the reliability of the device as more components need to be added to the device. So really, why does 400 gig matter today? And it's really because as we start to see the likes of Tomahawk 4 or some of the Jericho 2 chipsets start to be released, they are using native 100 gig serial or SerDes on those devices. And therefore, in order to kind of match them to a natural interface speeds, you're going to have to start to use 400 gig, which is using 4 lanes of 100 gig. Otherwise, as I said before, you kind of have to use a gearbox, which needs more cooling, more power, and becomes ultimately more expensive as well. Now, 400 gig is around today, but it uses basically 8 lanes of 50 gig to drive it. And you're probably familiar with using 40 gig, which is 4 lanes of 10, 100 gig, which is 4 lanes of 25. But then to use 400 gig today using 8 lanes becomes a bit unnatural, right? So you have to start to use different fiber to be able to support it, and it just doesn't work naturally with 400 with the kind of the fiber installs today. So probably best. Yeah.
Hi, Sean. Sorry to cut you there. You have a minute remaining.
Sure. Thank you, Portia. So it kind of makes sense to use 4 lanes of 100 gig for 400 gig, and therefore the natural match there would be the Tomahawk 4 with the 100 gig SerDes. And therefore, in order to go faster, the easiest way to go faster and the cheapest way to go faster is to go faster on the switching side. And very quickly, and I haven't got very long left, there's different options for 400 gig. Not one optic will meet every need, but probably the most interesting here is probably the ZR and the ZR Plus for long range, 100 kilometers to 1,000 kilometers. And what I'd say the most important part here is the fact that it's an industry first multi-vendor DWDM standard, which means that you don't have to have expensive DWDM equipment, proprietary equipment at both ends of the link. You could have one vendor at one side, another vendor at the other, and they would just work. And the beauty of ZR Plus is that we could cover the entirety of Europe. It's pretty much every link in here, bar a few, which could be covered by standard DWDM or standard 400 gig ZR Plus optics, without the need for expensive proprietary DWDM equipment in front of your routing and switching equipment as well. It does need external amplification, and you can kind of buy this today with a kind of built-in line system that's configurable and able to be monitored via the switch as well, to give you 120 kilometers over a single fiber and have 8 lanes of 400 gig, so 3.2 terabits over a single link. And there you go. And like I said, the easiest way to go faster is to go faster. And here are my details here. So thank you very much.